In this video, we will solve this question I have on the screen. So the question says that show that n to the power 3 plus 2n is divisible by 3 for every positive integer n. Now let's look at how to solve this question. Okay, so the first thing you have to do is the base case. Okay, so what you are going to do is that you are going to test whether what n to the power 3 plus 2n is divisible by 3 when n equals what 1, which is the first positive integer in this case. So you are going to take n to be equal to what 1. So we have what 1 to the power 3 plus what 2n. Sorry, 2 multiplying what 1, and this will be equal to what 1 plus 2, which will be equal to what 3. So I'm going to check if 3 is divisible by 3, and that is true because 3 is divisible by what by 3. Okay, so since it is true for what n equals 1, then let's assume that what it is true for n equals what a certain arbitrary positive integer k. Okay, so we call this step induct the inductive hypothesis. Okay, so with this step, we are going to assume this statement to be true for a certain positive integer k. Okay, so we therefore have k to the power 3 plus 2k to be divisible by what 3. So this means that when we divide this expression on top here with 3, we'll get what a whole number. Okay, so let's make this whole number x. Okay, so x is what some whole some whole number. Okay, so what this means is that if n equals 1 was proven to be true, then what we're going to assume that what it is true for what n equals k here also, which means what k to the power 3 plus 2k is also divisible by what 3. So we are assuming that what this is what true. So what we are going to do next is that if this is true for n equals k, then it must be true for the value that comes after what k, which is what k plus 1. So what we have to do is that we have to prove that what the statement will be true for what n equals what k plus 1 also. So now you will have what k plus 1 to the power 3 plus 2 multiply what k plus 1. Okay, and this can be written as what I can rewrite this in a different way by expanding this bracket here. Okay, so I'll use Pascal's triangle. So I have 1, 1, 1, 1, 2, 1. I have 1, 3, 3, and then 1. So expanding this bracket here, okay, that's what k to the power 3 plus 3k squared plus 3k plus 1. Then you come and add this bracket to it. So that's what plus 2 multiply with k plus what 1. So this will be equal to what k to the power 3 plus 3k squared plus 3k plus 1 plus 2k plus what 2. Okay, this is what you have now. Okay, so from here you go back to what the inductive hypothesis. Okay, where we said what k to the power 3 plus 2k divided by 3 will give what a certain whole number what x. Okay, so you can rewrite what we have here, okay, as what k to the power 3 plus 2k equals what 3x. Okay, equals 3x. I'll cross multiply, so I'll multiply this 3 with what this x here. What this means is that you can replace what k to the power 3 plus 2k with what 3x. So from this expression here, okay, you are going to write it in a way where we get what k to the power 3 plus what 2k from it. Okay, so rewriting this, I have what k to the power 3 and then I have 2k here. So I'm going to put these two terms. That was k to the power 3 plus what 2k. Then I'll now write the remaining terms. That was plus 3k squared plus 3k plus what 1 plus 2. That was plus what 3. Okay, so from here we know that what k to the power 3 plus 2k equals what 3x. So we can now substitute 3x here. So you have what 3x plus 3k squared plus 3k plus what 3. So you see that what 3 is common to all the terms here, so you can factor 3 out. So we have what 3 multiplying what x plus k squared plus k plus what 1. So therefore what we have here is that k plus 1 to the power 3 plus 2 multiplied with k plus 1 equals what 3 multiplied with x plus what k squared plus k plus what 1. Okay, so now we've written this expression here what in a different form. Okay, we've written this expression here what in a different form. So now let's see if it is what divisible by what 3. Okay. Okay, so now I have the expression to be half k plus 1 to the power 3 plus 2 multiplying k plus 1 to be equal to 3 multiplying what x plus k squared plus k plus what 1. So let's see what you have here is divisible by what 3. So I'm going to divide by 3. When I divide by 3, this 3 will cancel out what this 3. So therefore what it is divisible by 3. Okay. So what this means is that when you divide the expression on top by 3, we'll have what? We'll have, when you divide this expression on the top by 3, we'll have what? It to be equal to what? X plus k squared plus k plus what? 1. Since what? This x here is what? Some whole number. So therefore, we see that what? N to the power 3 plus 2n is divisible, by what? 3 for all positive integers n. Okay, there's no space there. That's why I'm trying to make it go there. Okay, so we see that what n to the power 3 plus 2n is divisible by 3 for all positive integers n.